Hello, everybody. Welcome to Little's Lab. My name is Kim. I am a community learning specialist with DoSpace. And for this month's theme, we are doing for Little's Lab is let's do experiments. So all month long, we are going to be doing really fun little experiments to help us learn some new things. And this week, we are going to be experimenting with magnets. But before we get started on learning what a magnet is and doing experiments with them, my first question for you is, what is an experiment? What is that? Do you know what an experiment is? I bet you do experiments every day. Every day you are doing experiments, especially if you're like a little, usually our Little's Lab is for 3 to 5 year olds, but even as you grow older and get to be an adult, a grown up, you'll be doing experiments almost every day, it seems like, because an experiment is basically learning the answer, asking a question, what will happen if I do this, and trying to figure out the answer. So a lot of times, we think about experiments with science, right? So a lot of times we think of science experiments, but there are so many types of experiments. And basically it's like finding out, a lot of times it's finding out, especially in science, like we're trying to get something to work, or we don't know the answer to something and we want to find out the answer. And so we have to do different things to try and get an answer. And sometimes a lot of times people make what's called a guess or a hypothesis. So a hypothesis is a guess of what they think that answer is going to be. Like somebody might ask a question like, how do clouds stay in the air? And somebody might hypothesize, well, I think clouds stay in the air because, I'm not really sure how clouds stay in the air. That's a very good question, because I should, maybe I need to do an experiment on that. But a lot of times, they're just water molecules that are lighter than the air down here, but people can make experiments on that. They can test that. So it's just like testing things. So they're testing, well, does this work? Is that the answer? And sometimes your hypothesis is correct, and sometimes it's not. And that's okay. And if your hypothesis or your guess isn't correct, you can always figure out a new hypothesis, try a new guess, and then make an experiment based off that. So basically an experiment is trying to find the answer to a question you may not know the answer to, and then testing it by doing different things. So for example, like I said, we are going to be experimenting with magnets, and I bet you are a little familiar with magnets. If you have a refrigerator and there are probably magnets on your refrigerator, then you know that a lot of times magnets kind of look like this, and there are certain things that will stick to them. So I have this little guy, and this little disc here is sticking to my magnet, and we're going to learn why it sticks, and then we're going to experiment. How we're going to experiment. Our question is going to be, what are some different items that will stick to a magnet, or will attract to a magnet, and then we're going to test some things. So we're going to test and be like, I think maybe this item does, and we'll test it and see if it does or not. And so that's how we are going to be experimenting with our magnets. And then I'm going to show you a little fun trick as well to do with a magnet if you have one. So yeah, so that's what we're going to be talking about and doing today. But before we get started with that, I would love us to, I always start out our Little's Lab with our calendar, because I think our calendar is so good to go over, because it helps us with our numbers and our days of the week, which is so important, and even with our letters. And so I am going to share with you my screen. And so you should be able to see now my screen, and you should be able to see a big blue screen with a triangle in the middle. And if we were at DoSpace doing Little's Lab, at DoSpace, we have this really great big basically touchscreen computer monitor. And I would ask my friends to come up and help me move this website along. But I can't have you, since we can't do that at Littles Lab here at DoSpace, I'm gonna have you pretend. So can you pretend with me? I want you to pretend to help me move things along. So what I'm going to ask you to do is I'm going to ask you to touch your screen, whether it's your computer screen or your iPad screen, however you're watching this video. And I want you to help me move our website along. So for example, you should see a big white triangle right here in the middle. Can you go ahead and touch that triangle? Go ahead and tap that triangle now. Excellent. So your screen should have changed. So you should see what our month is and then our year is. And so, yes, this is our month. And my question for you is, do you know what this letter is? What's our very first letter of the month that we're in? Do you know what this letter is? I'll give you a hint. It makes the j sound. And if you said July, you would be right. We are in the month of July. And we have a lot of months that start with that J sound, right? That start with the letter J. Last month, we were in the month of June. Our very first month of the year is called January. And so but right now we are in the month of July. And then this is our year that we're in. We are in the year 2020, 2020. That is our year. Perfect. So, okay, so you go ahead, you should see a green arrow on the bottom of your screen. Go ahead and touch that green arrow now. Excellent. So now you should see my calendar, the calendar that we're using. And I use the calendar at starfall.com. It's a really great little website, and I really like their calendar. So you should be able to see our month of July, and our year. And then you should also see our 7 days of the week. These are our 7 days of the week that we repeat every week and every month, all year long, every year. So we will always have our 7 days of the week. So it's so important to learn them, right? So let's say our 7 days of the week all together. I'm going to say them with you, and you say them with the people that you're with. So let's say them all together, and let's start with Sunday. So there's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Great job. And then do you know what today's day of the week is? Do you know what today is? If you said it's Saturday, you would be right. Today is Saturday. So all of our days right here are Saturdays. So not every date is a Saturday, but we're on a Saturday right now. So let's go ahead. You should see our golden Saturday right here on the right-hand side. Can you go ahead and touch that Saturday right now? Perfect. Yeah, so today is Saturday. That's our day of the week. Our month is called July. And then this is our date today. Our date today is right here. Does anybody know what the date is? Do you know what that number is? I bet you do. And if you don't, that's okay too. We're here to learn. And so our date has 2 ones. There's a 1 after a 1. And when 1 is after a 1, that makes the number 11. We are on the 11th day of June. So today is the 11th, of July, not June. Silly me. So we are on July 11th, and then this is our year 2020. Oh my goodness, I'm a year behind, friends. A year and a month behind. Whew. So let's touch our green arrow one more time. Okay, so now we need to drag and drop our Saturday and our 11th day of our month back into our calendar. So let's start with Saturday. So let's kind of just touch and drag that Saturday where it needs to go. Pretty easy because they're all right next to each other. Let's do the same with our 11th. Perfect. And let's touch that green arrow one more time. Yeah, so this is our month of July, not June, but July. And I really like this website's calendar because it gives little icons or pictures on kind of special days throughout our month. And I also like it because they're not always days that we celebrate here in the country that I live in. You might be watching this from anywhere over the across the world, and I live in the United States, and it doesn't always use show just dates that we celebrate in the United States. It'll show dates that are celebrated, primarily elsewhere in the world, which I really like too. So a really good example of that is our very first day of July, July 1st. You should see a little picture. That's a maple leaf. And that is a maple leaf because that is the maple tree is the national tree of Canada. And a maple leaf is that picture is something that represents Canada a lot of the time. And so it is Canada Day, and it's kind of a little bit like our Independence Day. It's that Canada Day is so it's the country that's straight north of the United States. If you ever look at a map, I love maps. I love looking at maps. And so if you've ever looked at a map, you've looked at a map of the United States, the country directly above the United States, up directly north of the United States is Canada, the big old country. And they used to be different sections called provinces, and they were kind of their own thing. And so Canada Day is the day that they all kind of came together to become one big country of Canada. So that's Canada Day. And then we have a really special day for here in the United States on July 4th, or 4th of July, which I bet if you're watching this and you live in the United States, then you probably celebrate the 4th of July. It's a wild holiday where we shoot off fireworks and we celebrate our independence. The United States used to be a part of a country called England, and then our country decided we wanted to be our own country. So that is our day of independence. We celebrate that on July 4th. And then there's not too much here in the middle, but then we do have a holiday down here on Friday, July 31st, and it is called Eid al-Adha. Pretty sure I'm pronouncing that right. And it is an Islamic holiday that is celebrated by the Muslim community. So if you are Muslim, and then you might be celebrating Eid al-Adha. And so that is that holiday. I don't know too much about it, but I do know that it's an Islamic holiday. And so I need to learn maybe why there's like a little sheepy with a bow on it. Maybe next week. But yeah, so, and I really like this calendar because it lets me, it has like a little piece of cake over here. So I like to ask people, do you have a birthday? Because everybody has a birthday, right? I have a birthday and you have a birthday. But do you have a birthday in our month of July? Do you have a birthday in our month of July? I don't have a birthday in my month of July, but I do know that I have a birthday for somebody special in my life. So I have a little baby who's going to be turning 1. So my daughter is going to be turning 1 year old on July 17th. So I'm going to bring over a piece of cake for July 17th because that's her birthday. And do you have a birthday? And if you don't, that's okay. But if you do, let me know in the chat. I would love to know if you have a birthday in our month of July. I'm not seeing any, so that's okay. Perfect. Well, we are going to move on. So I am going to stop sharing my screen now. So it's just me again. And yeah, like I said, we are going to be doing experiments or testing different things to learn how magnets work. And so like I said before, magnets are these really cool things. A lot of times people might see them, especially kiddos your age, will see them on like your refrigerator. So if you have a refrigerator, I bet you have a magnet, and you might be able to do some of these experiments with me if you have some magnets on your refrigerator. And so yeah, and if you've ever noticed, those magnets just stick right on that fridge, right? And sometimes they fall down. Like if you have something, a lot of times people will use a magnet to stick like a picture or a piece of paper or something on their fridge. And if that, if it's too thick, it might not stick all the way or it might not stick very good. And so, but there is a special material that is on our refrigerator that magnets are attracted to. So I have so many different magnets here with me. So I'm going to show you first off, this is kind of like a little circular magnet, and it will attract different things. So different things attract to it. And we're going to actually read a story about it to help us learn more about how magnets work and what they are attracted to, because we're going to find out that magnets don't stick to everything. So I could have something that, on our fridge that magnet will stick to, or if you have two magnets, you might be able to see if they stick together, because magnets can attract to each other. But then there are going to be some items that your magnet doesn't stick to or isn't attracted to. So we're going to read a little book that kind of helps us learn about that. So I'm going to share my screen with you one more time. And that one, perfect. And I'm hoping you can see my book. I'm at Epic Books, and we are going to be reading a little bit, not all of this book, but it's called Discover Magnets by Julia Vogel. And we are going to see how magnets work in a certain way. So, a mysterious force. You can't see it and you can't hear it, but it has the power to push and pull. It's inside Earth and everywhere around your home. What is this mysterious force? It's the power of magnets. And so you can see here, over here on this side of the book, that it says down here, the force of magnets holds these little screws tight. And that magnet looks a lot like mine, and look at all of those screws that it is holding on tightly to. So that just gives you another example of how magnets work. Will it stick? You know that magnets stick to a fridge. We've talked about that just now. But why? The door has a thin color coating, but underneath there's metal. So a lot of times magnets are attracted to metal. So magnets attract certain kinds of metal. Most often, magnets stick to iron. They can also pull on other magnets, which we talked about. So iron is a really good metal that magnets stick to. So right down here it says nails have a lot of iron. Would they stick to a magnet? What do you think? Yeah, if nails have if they're made up of a lot of iron, then they would stick to a magnet. And up here you can see thumbtacks and needles would stick to magnets. And a piece of string would not, because it's string metal? No, it's not metal. But like our previous book page said, not all metals stick to magnets. So pennies don't scoot to a magnet, and neither does gold. Paper and pencils stay put too. These things are not made of iron. They are magnetic. Ooh, excuse me, I thought I was about to sneeze and I didn't want to blow out your hearing with that. I think we're good. So coins are the wrong type of metal to be sticking to magnets, which is probably pretty good, right? Because if pennies and quarters and nickels and dimes, if attracted to magnets, that it would be really easy to take them out of places, or maybe if they were made in a way that had magnets, the machinery that made them use magnets, then they would get stuck to those magnets, and we wouldn't want that either. So it's probably pretty good that our coins aren't magnetic. So things made of paper, plastic, or wood will not stick to magnets. Okay, so remember that. So remember that things made of plastic, paper, or wood will not stick to magnets. That's going to be important for our experiments. So magnets come in different shapes and sizes. Which one can pick up the most stuff? It may not be the biggest one. Even really small magnets can grab things they're not touching. Hold a refrigerator magnet above a paper clip. You can make that paper clip jump. So we have down here this tiny little magnet, and it can attract all of these paper clips to it. But then this is a really big magnet over here. This is a magnet at like a junkyard. And so this big magnet are ones that are used in junkyards. So I'm going to show you how sometimes, yeah, magnets, they have different forces of attraction. So sometimes they have a lot of attraction, so they can grab a lot of things, and some of them can't. And I'm going to show you how sometimes even magnets can attract things that they're not touching. I'm going to show you, and we're going to do an experiment with that. But even like little teeny magnets can be much more can be much stronger than bigger ones, which is why you don't always want to play with magnets by yourself. Make sure you have a grown-up around with you, because magnets can be dangerous if they're too strong. But what happens if you move the paper clip across the room? The trick doesn't work, because around each magnet there is an invisible space. This space is called a magnetic field, and the magnet only works within that field. So you could see here that all these dotted lines are its magnetic field. So if we had like a nail, we had one of those iron nails, and we had it really close to our magnet, it would stick to our magnet. That's right here. But if it was outside over here, in this space, it wouldn't be attracted to it. So planet magnet. Did you know that what's the biggest magnet on Earth? It's Earth itself. Earth has a magnetic field. So if you think just like this, we have an N for north and an S for south. So this magnet has a north pole and a south pole. What else has a north pole and a south pole? The planet Earth, right? Because like Santa Claus lives on the North Pole, right? And then we have penguins that live on the South Pole. And so our Earth is kind of like a big magnet. And Earth has its own magnetic field as well that go around it, which allow for things like compasses to work. So I have a tiny little compass. Where's that at? So I have this tiny little compass, and that's how compasses work. That's how we are able to know which direction is north and south with a compass, is because of the Earth's magnetic field, which is pretty cool. So yeah, I'm actually going to stop our book right there, because I want to make sure that we have time for our experiments. I'm just going to keep this little image up for just a second, because I want to show you some things. So like I said, I have lots of magnets, right? I have my own lots of magnets. So I have my own magnet that looks like, and it's kind of hard to see. I'll make sure. So you should be able to see where it says an N over here and an S over here, and it might be backwards. Could be. What if I did this? That looks a little bit better, I think. But anyway, this side is an N for our North Pole, and this side is an S for our South Pole. And every magnet is polarized. Every magnet has a North Pole and a South Pole. So even our little guy right here, even though it's a circle, it has a North Pole side and a South Pole side. So, and we can test that. We can tell which side, even though they're not, like on this one, is labeled, I'll be able to know which side is the North Pole side and which is the South Pole side, because this one is already labeled. And with magnets, opposites attract. So the North Pole and South Pole of each magnet will attract to each other. So for example, and then if two North Poles come by each other, they'll push away each other. They don't want to hang out. The two North Poles, they don't want to hang out. But a North Pole and a South Pole, they're like, let's be best friends. So you can see I'm trying to push together the two sides of this magnet, and they are not coming together, right? And if you were here, you could actually feel a force. I can't see it and I can't hear it, but there is a force that's coming in between these two magnets. And so they are not sticking. I could try and the south side, but So that's the south side, right? So I know that this side right here of my magnet is the south pole because this is the south pole of my, of this magnet. So if I turn it around and I go to the north pole, let's see what happens now. It immediately attracts each other. Look at that. So I now know that this is the south pole side and this is the north pole side. So I just turned it around. This side that I'm sure is the north pole. They don't want to stick. And that's the same with all types of magnets, right? So that's pretty cool. So I'm actually going to stop sharing here so you can see a little bit bigger because we are going to do some experiments. So we talked about how magnets are attracted to metal and a lot of times they're attracted to iron. So I have a really cool magnet wand here, and we know it's a magnet wand because I can stick this magnet to it, and there are some other things I know can help me. So for example, I have this paper clip. We talked about how paper clips a lot of times. So I also know that this is a magnet because boom, my paper clip goes directly onto and is attracted and sticks to my magnet wand. So this is what we're going to do, friends. We are going to do some experimenting, and you guys, we are going to kind of do a little bit of hypothesizing or guessing. So how we're going to do this is I have some items over here beside me, and I'm going to show them to you, and I want you to hypothesize or guess if you think it will stick or attract to my magnet wand or if it won't. So I want you, with the person that you're with, the people you're watching with, I want you to say, yes, it is magnetic. And if it's magnetic, things that are magnetic, then will stick to a magnet. And then if it's not magnetic, it will not stick. So I have some things. So let's do some experimenting. So for example, I have this metal, it's like a little metal wrench. What do you think? Is this wrench magnetic or not magnetic? Let's find out. It is. It's magnetic. This metal wrench is magnetic. It goes right on. It is magnetic. Perfect. Did you say that it was magnetic? Okay, let's do our next one. I have this piece of foam cube. I have a foam cube. What do you think? Is this magnetic or not magnetic? I'm gonna put it on here, and then it's not. This isn't magnetic. It's a piece of foam. It's kind of like plastic. So foam is not magnetic. Did you hypothesize that? Did you say it was not magnetic? Okay, let's try a few more. I have this plastic ball. Let's see if it's magnetic. Is it magnetic? We'll find out. Nope, it's not. It is not magnetic. This, like I said, just like our foam, like our book said, plastic is not magnetic. So this doesn't. But then I also have this kind of round circular thing. Let's see if this is magnetic. It is. This is magnetic. This actually has a magnet in it. So this was kind of tricky. You can kind of see how this side does not want to. You can kind of even, if you do that, you can kind of almost see the field because that's where it kind of bounces off. But this is actually a magnet too. And then our last thing, I have some Play-Doh. Ooh, this is kind of tricky, right? Because it's not plastic and it's not wood. It's not foam. What do you think? Is Play-Doh magnetic or not magnetic? What do you think? Let's find out. Is it magnetic or not magnetic? It's not magnetic. Play-Doh doesn't have any iron in it, no metal. So it is not magnetic. So those are some of my experiments. But I also have a fun just like trick that I want to show you because, and this will kind of help show about the field and how that field works. That's kind of that area right in our book. And I talked about how magnets don't have to necessarily touch the thing to be able to attract something. So I have this paper clip, right? And we have our paper clip that's attracted to our magnet. And remember, our string is not, our string isn't. But this is what I'm going to do. I'm going to hold one side of our paper clip, and then I'm going to kind of get it to attract, and then I'm going to do this. I'm pulling on the string a little bit, and you can see how our paper clip is being held up, even though, oh, I went too far. So right now, it's not attracting. And we'll see as did you see that? It just went right, it just made it go straight to it. As we get closer, as it gets closer, it gets into its field of this magnetic field. And so then it can still attract, and it's kind of like a little magic trick, right? It's like a flying paper clip. Very cool. Okay, friends. Well, those are some of my experiments and things to learn about magnets today. So I want you, if you have some magnets at home, maybe some kitchen magnets, those are the best kind because they're not too strong, but they're just strong enough to kind of test things out. Go around the house. I want you to make some hypotheses. Make some guesses about some items around your house and test them. Are these things magnetic, or are they not magnetic? And do some experimenting this week with some magnets. Okay, friends. Well, that is it for me today. Thank you so much for joining me for Little's Lab. And next week, we are going to be kind of doing experiments with some water. So we are going to experimenting with things that float and don't float. And we're going to be, I think that might be all we have time for. And if we have a little bit of time, we'll talk about kind of like densities of things. So we're going to be doing some cool things next week as well. So join us next week, next Saturday for Little's Lab, and we'll be doing experiments with water. I hope you have a good rest of your day, and we'll see you soon. Bye.